Okay, hello everyone. Those of you who are watching this recording at a later time, most likely from home, welcome. This is our review for exam 2, which is on sections 8.1 through 8.9. And if you recall from lecture today, how I said there will be 4 free response questions, and there's 6 different types it could be, right? It could be a single sample confidence interval, single sample hypothesis test, paired sample confidence interval, paired sample hypothesis test, or 2 independent samples, confidence interval, 2 independent samples, hypothesis test. Those are the 6 options. 4 of them will be the free response on the exam, plus maybe a little bit additional extra. Remember, as I said, there could be a little bit critical thinking questions on there too. And this review, how many questions does it have? 6. So, guess what? We're doing 1 of each type. Okay, so we're going to see 1 of each type. They are not in any particular order, because on the exam they may not be in any particular order. But we will see 1 of each type. Okay, so number 1. The following data represents a random sample of the average price of textbooks sold at several community colleges' bookstores. Okay, I typed this, so any typos are on me. There's definitely a typo here. Community colleges bookstore. Construct and interpret a 99% confidence interval for the population mean price of textbooks sold. It's not asking for it, but I want you to first practice with your flow chart, okay? For sure, we're working in chapter 8, so this quantitative data. Is this 1 sample, paired sampled, or 2 independent samples? This is 1 sample. And are we doing a confidence interval or hypothesis test? Confidence interval, good. So from your flow chart, you should go to the 1 sample confidence interval. All right, what is the mean price of textbooks? So you're going to take your calculator, type in all the data into your calculator. You're going to press stat, edit, clear out any old stuff, and into L1 type in the data. 65, 40, 74, 16, 56, 36, 42, and 110. Once you've entered in your data, you press stat again, go over to calc, and then the very first option, 1 var stats. You may have to enter a few times. Make sure your list says list 1, okay, because that's where we typed in our data. And the mean price of the textbooks, you should get X bar equals 54.875. What is the standard deviation of the sample? Well, that also comes from your calculator, so don't clear that out. It should be right there as well. Our sample standard deviation is 28.693. It doesn't say, but we're just going to round to 3 decimal places for this. On the exam, it should say where to round. Degrees of freedom. Degrees of freedom. Remember, if you forgot, it is also on the formula sheet. For a 1 sample confidence interval, just go 1 more box over to the right. It says degrees of freedom equals n minus 1. Where n is the sample size. What is the sample size here? 8. 8 minus 1 will give us 7. So the degrees of freedom is 7. What is the critical value? So, remember, to identify the critical value, you need your degrees of freedom, which we said was 7, and you need your confidence level, which was 99%. So using these 2 pieces of information, and let me actually go ahead and open up the, let me go ahead and open up the formula sheet, because we're going to be referencing it. So I am using this one, the traditional math 21B exam 2 formulas. If you just scroll down, there is your T critical value chart. Okay, so the degrees of freedom we said was 7. What was the confidence interval or level? 99. So using that chart where 99% and the 7 intersect, are you guys seeing 3.499? Yes, good. So that is 3.499. So next, let's find the margin of error. You do not need to know the margin of error off the top of your head. It is provided on your flow chart. The one sample to the confidence interval gives us that E equals the critical value, T sub C, times S over the square root of N. You guys okay with that? Okay. Where we have all pieces of information, the critical value we said is 3.499 times S, we said is 28.693 over the square root of N, where the sample size is 8. Plugging this into our calculators, 3.499 times 28.693 over the square root of 8. Rounding to 3 decimal places is 35.496. All right, so what is the confidence interval? And in case you forgot, once again, look to your flow chart, look to your formula sheet. It tells you how to find the confidence interval. It says to do x bar minus E, comma, x bar plus E. And we found what x bar was previously. We found that in part A. We said that was 54.875. So it's 54.875 minus E, so minus 35.496, comma, 54.875 plus E, plus that 35.496. You're going to enter in each of those individually in your calculator. So first, subtract those values. Minus 35.496. And you get, oops, not the eraser. And you'll get 19.379. Then add those values, and you get 90.371. So that is the confidence interval. Now, I know we've been rounding to 3 decimal places, but remind me, what is this problem talking about, really?
Price.
The price of textbooks. So how many decimals should we go to, because it's the price of textbooks? 2 decimals. So let's just say this is 19.38 and 90.37. And again, on the exam itself, it would specify at each step where to round. So just be extra careful making sure you're rounding appropriately. But in this case, it makes sense to go to 2 because we're dealing with money. Next, interpret the confidence interval in the context of the problem. What was our confidence level? 99%. Okay, so we are 99% confident that, and if you forgot what the heck you're talking about, guys, please go back to the problem. I forget all the time, okay? It's like I've been doing all this math. I don't even remember what I was doing this for. So let's go back and let's see. Okay, so we want to construct a 99% confidence interval for the population mean price of textbooks sold. So we are 99% confident that the mean price of textbooks sold is between $19.38 and $90.37. Do we know what the actual mean or average is? No. But I'm 99% confident that's between those two values. So I know it's not going to be less than 19 and not more than 90. Well, I shouldn't guarantee that, but I'm 99% confident that that's the case. I want to throw a couple additional questions at you. I'm not going to write them down. I'm just going to say them out loud. But any questions up to here before I throw more stuff at you? Okay, so let me ask you. You've done all this work, right? And then someone from the college, some representative or whatever, comes up to you and is like, oh, I'm pretty sure the average cost of the textbooks here sold on campus is $60.05. Would you say that's okay? That's reasonable?
No.
What do you guys think?
No.
Yes. Yes. But why?
False.
Because $60.05 is between 19 and 90. So that's okay. Versus what if someone came up to you and is like, the average price of textbooks sold on this campus is $15. Yeah, that would not be reasonable, right? We would say, I don't really believe you because $15 is outside of our interval. Same thing if we went on the opposite end. If the individual said, oh, I'm pretty confident the average price of textbooks is $120, once again you would say, no, I don't think so, because $120 is outside of that interval. So anything in between those two values, that's a good and reasonable statement. You can't say it with certainty, but we're pretty confident it's in between those two values. Anything outside of it will be like, I don't think so, right? Does that make sense? Okay. I'm going to try to keep just throwing stuff at you. Just critical thinking. Okay. Number 2. Let's read it together, and then I'll pause the video so you guys can work on it a little bit before we go over it. Okay? So number 2. A random sample of 20 schools in 2017 had a mean number of student awards of 50 and a standard deviation of 25. In 2018, a random sample of 25 schools had a mean number, had a mean number of student awards of 70 and a standard deviation of 35. Assume the number of student awards is normally distributed. Test the claim that the number of student awards increased between 2018 and 2017. Use significance level 5% and degrees of freedom 43. All right, I'm going to pause the video. Okay, so what are the null and alternative let me back up. First of all, is this one sample, paired samples, or 2 independent samples? 2 independent. And then is this hypothesis test or confidence interval? Hypothesis test. Good. So you know where to go on your flow chart. 2 independent hypotheses test. So what are the null and alternative hypotheses? So let's start with the null. What's the null?
M1 equals M2.
Yeah, mu1 equals mu2. Be careful here. This one's a little bit tricky. It wasn't intended to be tricky, but it just turned out that way. We know we're comparing mu1 and mu2. Is it less than, greater than, or different from?
Greater than.
It's going to be less than. It's going to be less than. And let's think about why. This was definitely tricky. It was easy to mix up because it says, where did it go? Test the claim that the number of students awards increased between 2017 and 2018. So if it's increasing from 2017 to 2018, which one's larger? 2018. The second group should be larger. The first group is smaller than, less than the second group. The number of awards in 2017 is less than the number of awards in 2018 if we're assuming that the number of awards will be increasing over time. Okay, so be careful, guys. Just, when it comes to these guys, just triple check, reread it, okay? Are the normality criteria satisfied?
Yes.
Yes. Why?
The samples are greater than 30.
Let's see here.
Oh, never mind.
Does it state it? Oh, yeah, it says right here. Assume assume the number of student awards, excuse me, is normally distributed. Okay. So yes, we are told, I'm just going to say assume normally distributed. Okay. List the sample statistics. If this were to be on the exam, I would explicitly say like what exactly I'm looking for here. But basically when it says list the sample statistics, it's just organize your data. That's all I want. Just organize the data from the two groups. So the first group was 2017. Okay, so, oops, why does it keep going to eraser? So for 2017, let's see. The sample size was 20, because this is a random sample of 20. The mean was 50 with a standard deviation of 25. And then in 2018, and you may have organized this a little bit differently, but again, just so long as it's organized. So 2018 is our second group. 2018, a sample of 25 schools, mean number of 70, with a sample standard deviation of 35. Yeah. So next, let's compute the difference of sample means. So that means just to subtract x bar 1 and x bar 2, right? That's the difference of the means. So that'll be 50 minus 70, which is negative 20. Calculate the test statistic, that is from their formula sheet. Going to the two independent samples in the hypotheses test, that's x1 bar minus x2 bar, all over the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So you have a couple options here for the numerator, the x1 bar minus x2 bar, because he did just do it in part D. All right, so you could just immediately plug in negative 20 if you wanted to. Or if you wanted to rewrite it as the 50 minus 70, that's fine as well. Whatever you're more comfortable with. Over the square root of, let's see, this will be 25 squared over 20 plus 35 squared over 25. And let me see what this gives us. So negative 20 over square root of 25 squared over 20 plus 35 squared over 25. I'm going to round this to 3 decimal places. I got negative 2.233. Okay. So next, let's find the p-value. There'll be TCDF. The lower bound is negative infinity. And the upper bound is negative 2.233. And the degrees of freedom was given, right? Degrees of freedom is 43. So let's see. TCDF, negative infinity, negative 2.233, and 43. Let's go to 3 decimal places. That'll be 0.015. And something I just want to point out real quick, because I know some of you guys were confused on this step right here, right? Or like, is it less than, is it greater than, right? Well, remember, the value you have here should match the sign that you get for your t-score. So since this was negative, that matches that this is going to the left towards negative infinity. Okay? So if this were positive, then you would be like, oh crap, I more than likely made a mistake. Right? Because if your t-score is positive, then you would expect it to be going towards the right, towards positive infinity. So that's just a helpful little trick in case you're getting stumped on here. You can be like, okay, well, let me just go ahead and continue as usual. Let me see what my t-score is, because more than likely they should match. And since these are matching, it's like, okay, I can breathe. you know.
I got a complete different answer for the C
Did you do it like this?
Yes.
Can I see your calculator?
No. Yes.
Let me take a quick look. Oh, very close. You put negative 2.333, but it should be negative 2.233.
Oh,
There you go. Yeah, there's a little differences, right? Okay. So then what can you conclude about the null and the alternative? Well, the p-value is 1.5%. What was our significance level? Was it 5%? I forgot.
Yeah.
5%, okay. So this means it is statistically significant, which tells us to reject the null and support the alternative. It's not asking for it, but if it did ask for what type of error could have happened here, what would you say?
Type 1.
Type 1 error. Good. And then write a conclusion in the context of the problem. At the 5% significance level, the sample data support the claim that, and honestly, I forgot what the claim was. So let's go back and see what the claim was. Test the claim that, it says right here, the number of student awards increased between 2017 and 2018. So that the number of student awards increased between 2017 and 2018. Any questions? You guys feel okay? All right, 2 down, 4 to go. So question number 3. A sample of students receiving financial aid was conducted on the time it took to process their application. The table below lists a random sample of application completion times in days. Assuming financial aid completion times are normally distributed, use a significance level of 5% to test whether the population mean response time is less than 60 days. So it's giving us the data. It took a random sample of 14 students, it looks like, and it gave us how many days it took to complete the financial aid application. So I'm going to pause the video. And I want you guys to work. Okay, so first of all, what type of problem is this? I know it's not asking it, but we should always be starting with that. Is this a single sample, paired samples, or 2 independent samples? Single samples, good. And is this a confidence interval or hypothesis test? Hypothesis test. Good. Oops, I almost wrote good. Hypothesis test. So that way when you're looking on your flow chart, you go to the 1 sample and then hypothesis test to know what formulas to use. All right, so what is the null and alternative hypotheses? Let's start with the null. Mu what? Equals 60. Okay, equals 60, because that's the baseline. All right, that's the baseline. Was that Siri?
My phone just went,
Oh, we're even teaching Siri. So mu equals 60, because remember, we only have 1 sample. There's nothing else to compare it to. So your baseline is going to come from the problem itself. And we want to know is in comparison to 60 days. So we're starting off with a baseline of 60 days. And then the alternative is that mu is what? is less than 60 days because it says right here, we want to test the claim whether the population mean response time is less than 60 days. Okay, and remember, these two numbers should always match. That's another hint. These two numbers should always match. So when it says less than 60 days, you know your alternative is going to be mu is less than 60. So that means your null should be equaling 60. Okay. Are the normality criteria met?
Yes.
Yes. How do we know?
Assuming financial aid completion times are normally distributed.
Yep. It says right here, assume financial aid completion times are normally distributed. Yes. Assume, and I'm just going to shorthand it, normally distributed. All right, we're told that. If we weren't told that, what would we have to check?
Sample size.
Sample size would have to be greater than 30. Good. Okay, sample statistics. So let's start with our sample size. What's the sample size?
14.
14, good. And then we also want the sample mean and the sample standard deviation, which we got to get that from our calculators. So you're going to press stat, edit, clear out any old data. So it'll be 61, 32, 50, 73, 51, 42, 55, 65, 59, 57, 76, 77, 67, and 71. So enter in the new data into list 1, press stat again, go over to calc, and then the very first option, 1 var stats. Make sure it's for list 1. Let's round these to 3 decimal places. You should get the mean to be 59.714 and the standard deviation to be 13.106 once you round to 3 decimals. And again, on the test, it wouldn't just say list the sample statistics. It would say n equals, x bar equals, s equals, or explicitly say find the sample mean, find the sample standard deviation. It would list it out. Okay, so calculate the test statistic. Well, again, from your formula sheet, we said this was one sample hypothesis test. So use that flow chart to determine what formula to use. And we're going to use that t equals x bar minus mu over s over the square root of n, which we have all those pieces of information. So let's substitute it in. That'll be 59.714 minus 60 all over 13.106 over the square root of 14. And let's see what we get. And I plug this in my calculator as well. 59.714 minus 60 over 13.106 over the square root of 14. Rounding this to 3 decimal places is negative 0.082. And again, this is a good opportunity to check. This is negative, and this is less than, going to the left towards negative infinity. So that's like a good indicator that you're on the right track. Again, it's not guaranteed, but usually you could expect it to be the case. So next is the p-value. The p-value equals TCDF. This is a left tail, so it'll be negative 9999999, negative infinity. Then negative 0.082, followed by the degrees of freedom. What's the degrees of freedom in this case? 13. 13, because the sample size is 14.
Oh.
And then 14 minus 1 is 13.
Sorry.
That's okay. So that will be negative infinity, negative 0.082, and 13. And I'm going to go 3 decimal places to get 0.468.
I have a funky question for
Mhm.
you. I read it wrong for some reason. I put 9 for my degrees of freedom, and I got the exact same answer.
Coincidence.
Coincidence?
Yeah, it just depends.
There's
It
no
really
way
just
to range.
depends.
Okay,
It really just depends.
gotcha.
Like,
I got 40.
yeah.
Okay.
Question?
Why for when we did the 2 independent hypothesis test for number 2, we didn't subtract the degrees of freedom, but for the one sample into.
So good question. So in this problem, we were literally just given degrees of freedom. Degrees of freedom is 43. That's it. Done. Degrees of freedom is known to be 43.
So we didn't have to find it.
We didn't have to find it. Exactly. Whereas in this problem, we're not given that information. We actually have to calculate the degrees of freedom. And to calculate it, that's where you need to take the sample size and subtract 1.
Okay, thank you.
Mm-hmm. Okay, what can we conclude about the null and alternative? Well, our p-value is 46.8%. What was our significance level? 5%. So is 46.8 less than 5%? No, that is not a true statement. Therefore, it is not statistically significant. Therefore, we do not reject the null, and we do not support the alternative. It's not asking for it, but if it were to ask you what type of error to be on the lookout for, would it be type 1 or type 2? Type 2, good. Lastly, write a conclusion in the context of the problem. Well, at the 5% significance level, the sample data do not support the claim that do not support the claim that and then feel free to look back because I for sure forgot what the claim was. Let's see here. Whether the population mean response time is less than 60 days, right? For the financial aid to be completed. So does not support the claim that the financial aid will be completed in less than 60 days. So it does not support the claim. It does not support the claim that that financial aid application will be completed in less than 60 days. Any questions? Yes.
So when I'm putting in the p-value, I'm getting a different number too.
Can I take a look?
Yeah.
Oh, you're missing a 0. That's why. You have 0.82, but it should be 0.082. There you go.
Thank you.
Yeah, those little things, they get us. They keep getting us. Any other questions? All right, guys, we're halfway. We've done, so remember there's 6 different types of questions. We've done 3 of them. Let's keep going. Number 4. An English instructor suggests that working in groups will improve your exam score by around 5 points. A random sample of 5 students took exams, first before and then after forming study groups. Construct a 90% confidence interval to see if the instructor's statement has validity. All right, guys, I'm going to give you 5 minutes. Let me pause the recording. All right, so to start, is this single sample, paired samples, or 2 independent samples? Paired, good. And then confidence interval or hypothesis test? Confidence interval, good. All right, so part A, calculate the differences for each student in the table. For those of you online, I explained this to those in person, but I want to say it here again. Normally, like 99% of the time, you're just going to subtract it in the order as you see it, pre minus post, like 70 minus 85, 50 minus 45, and so on. But be careful. I'm going to just be very explicitly clear on the exam in terms of what order I want it in. In this case, on this review, I decided to make it post minus pre. So we're actually going to be doing 85 minus 70. 45 minus 50, 87 minus 80, and so on. I'm trying to recall why I made it that way. I think it's just because the numbers worked out better. But just so you can sigh a breath of relief on the exam, I will be explicitly saying what order to do it here, just so you're extra sure, okay? So we first need to do those subtractions. So we're going to do post minus pre for each of these. 85 minus 70 is 15. 45 minus 50, negative 5. 87 minus 80 is 7. 95 minus 82 is 7. 13?
13.
Okay. See, I can't do math in my head. 13, thank you. 84 minus 74, I got that one. That's 10. Okay. Part B, what is the sample statistics? And again, on the exam, I would explicitly write out exactly what I want here. I want the sample size. So what's the sample size in this case? 5. And then I also want the sample mean and the standard deviation, which need to enter our differences in our calculator. So we're going to do stat, edit, clear out your L1. And again, we're just typing in the differences because we already wrote them out in the box. These numbers weren't that bad to do. So it's 15, negative 5, 7, 13, and 10. You do stat, calc, 1var stats. So I got the sample mean to be 8. And sample standard deviation, I got 7.874. Okay, cool. All right, degrees of freedom. They are not given to us. We need to calculate it. We know that's equal to the sample size minus 1, which in this case will be 5 minus 1, or 4. What is the critical value? Well, to find the critical value, there's 2 pieces of information we need. We need the degrees of freedom, which we just said was 4, and we need the confidence level, which we were told is 90%. So based off of these 2 pieces of information, we could use that table that's on your formula sheet. So 4 and 90%. So 4 and 90%, did you guys get 2.132?
Yes.
Okay, 2.132. That is the critical value. All right. Now we can find the margin of error. Again, feel free, look to your formula sheet to determine which formula you're supposed to be using here. We said that this was paired sample confidence interval. So paired sample confidence interval, the margin of error is the critical value times the standard deviation over the square root of n. So it's going to be 2.132 times 7.874 over the square root of 5. So 2.132 times 7.874 over the square root of 5. And we get 7.508, rounding that to 3 decimal places. Then, what is the confidence interval? Still from your formula sheet, in case you forget, that's x bar minus e and x bar plus e. Where the mean we said was 8, so that's going to be 8 plus, minus comes first. 8 minus 7.508, comma, 8 plus 7.508. And we do those separately in our calculators. So first you subtract those values. And you should get 0.492. Next, we add those values. And you get 15.508. Interpret the confidence interval in the context of the problem. And again, feel free to remind yourself, what were we talking about here? So we were talking about the difference in students' exam scores after they took after they did it with a study group, after they studied with a study group versus before when they didn't study with a study group, right? So we're saying, what was the confidence level? 90%. We are 90% confident that the difference mean in exam scores after and before studying in a group is between 0.492 and 15.508. I'll let you finish copying that, and then I'm going to throw some extra questions at you. Okay, so let me throw some questions at you. What are we really saying here? Are we expecting the exam scores to be higher pre-study group or post-study group? Post-study group. Why? Because it's only a positive result. We only have a positive interval here, right? And remember the order that we did our subtraction. We did post-study group minus pre-study group, right? And we're saying that no matter what, it's going to be a positive number because our confidence interval is only positive. And the only way to get a positive number is that if you get a higher score post-study group and you have a lower score pre-study group. Okay. What would happen if instead of these both being positive, what if these are both negative? Then what would we say? That students had a higher score after they studied in a study group or before when they didn't study in a study group? Before when they didn't study in a study group, right? If these were negative values, then that means this will be a smaller number and this is a higher number. So that means they got a higher score when they studied alone. Right? Maybe because the study group wasn't really a study group and it was just like a distraction party or something, right? The intentions were there, but it didn't pan out. And then what if you had a mix of positive and negative here? Can you really come to any conclusion? No. Because then it'll be like, It could be that the study group is beneficial. It could be the study group is not beneficial. It could be that they're exactly the same and it has no difference. What if a teacher, right? What if a teacher now wants to say to their students, like, hey guys, if you study in a study group, I'm really confident that you're going to get 20 points higher on your next exam. Is that reasonable? No, because 20 points is outside of this range. What if the teacher were to say, hey guys, if you were to study in a study group, I'm really confident that you're going to get 10 points higher on your exam. That's reasonable because 10 is within this interval. It's a possibility that could happen. Okay. Good. Any questions? Yes.
I heard these numbers, but I'm getting different numbers for.
for my list. Oh, the first
Oh, first
value
ones, I
is
just-
15. There you go. No worries. Any other questions?
How should we know to write that exactly, that the difference mean in exam scores? Like that phrase?
So when it comes to paired samples, we're always finding the difference.
Okay.
Always. So automatically you know so in general, we're talking about the averages, but specifically with paired samples, we're talking about the differences in the averages.
Okay.
Yeah. We're always talking about the means, but
Okay.
then with paired, more specifically, we're subtracting them. So.
Okay, thank you.
Mm-hmm. Any other questions? All right, we got 2 more. Number 5. A Statway student claims that solely attending the tutorials and not doing the online Realize It homework will improve your exam score. A random sample of 5 students who did not complete their online assignment took math exams, first before and then after attending the tutorials. Test the claim using a level of significance of 10%. Assume normality. Hint to use pre minus post. So again, I'm specifically clarifying what order I want you to do the subtraction here. So in this case, it's pre minus post. All right, guys, I'm going to give you 5 minutes. Okay, so this one is starting off with wanting us to write the null and alternative hypothesis. Oh, wait, I got to back up. Let's first identify what type of question this is. So first of all, is this a 1 sample, paired samples, or 2 independent samples?
One time?
Paired. This is paired. It's paired because, again, we're going to do a pre and a post, right? The same student, right? Same student, just measuring pre-tutorial and then post-tutorial. So paired samples, and then confidence interval or hypotheses test? Hypotheses test. Okay. So part A, what are the null and alternative hypotheses? So what is the null? Mu equals 0, very good. And then the alternative, we know it's still mu and 0, but we have to determine if mu is greater than, less than, or different from, which that's usually the tricky part. And remember, for the paired samples hypotheses testing, I always recommend you just write it off to the side a little bit. Like write it out a little bit to make sense to yourself, okay? So that's what I'm going to do. So it tells us what order it wants it in. It's telling us to do pre-tutorial, right? Pre-tutorial minus post-tutorial, okay? And this student is saying that by doing the tutorial, or what they're claiming, I should say, what the student is claiming is that by doing the tutorial, the exam scores will improve. So tell me, pre-tutorial is at a lower exam score or higher exam score? Pre-tutorial. There'll be a lower score, right? There'll be a lower score. Post-tutorial, the student is claiming that you'll have a higher score. So if that's the case, a lower score minus a higher score, will that result in a positive or negative value? Negative. Therefore, this is a left tail. And, yep.
Just a random, like, out of the blue, how would I know if it's positive? Because I just guessed that it was left-tailed and...
So this question could have very well been positive if the order was simply swapped. If this was a post minus pre, then you would have a higher score minus a lower score. That would be a positive result. So there's no, just by reading it, I would say that for me at least personally, I don't know off the top of my head. Just by reading it, I don't know if it's going to be less than or greater than. I personally, I have to write it out to the side, like taking the order I'm subtracting it in and like putting it into context. Like, okay, this student is saying that before the tutorial, I'm going to have a lower exam score, and after the tutorial, I'm going to have a higher exam score. So if I were to subtract those, I get a negative number. Okay, like I have to write it out. There's no way just to, for me at least, there's no way to just know if it's going to be less than or positive. Like I need to put it into the actual scenario.
Can we also just use like, where it says, where the teacher saying like a random sample of 5 students who did not complete their online? Because they're saying not and not, can we just also
No.
assume that it's negative?
No. Yeah, it's saying that they didn't complete their homework has no bearing whatsoever on whether it's negative or positive.
So so if it's post for first,
Mhm.
mine is pre, that would be a positive?
In this case, yeah.
You just always have to read.
It totally depends on the problem.
Yeah.
Because what if instead, this question had nothing to do with like exam scores and tutorials, you know? What if instead this had to do with measuring, let's say, hold on, give me a second here. Let's say this had to do with measuring, so pre minus post. Pre minus post. Sad levels of a dog. Let's say that we could measure that, okay? Like how sad a dog is pre their owners coming home and post their owners coming home, right? Now, okay, I'm just totally making this up. I'm going to erase it, but let me write it out. So let's just pretend that this had to do with how the level of how sad a dog is. The higher the number, the more sad the dog is. The lower the number, the less sad the dog is. Okay? So let's say before family is home minus after the family is home. Okay, and we're measuring the sadness level. So before the family is home, what do you expect the sadness level to be? Will it be higher or lower? It'll be higher, right? It'll be higher. Maybe it'll be like 85 or something. Poor dog is all alone, you know? Minus after the family comes home, what do you expect the sadness level to be?
Lower.
Lower. Like hopefully it's 0, right? But let's just say it's like 5. Okay, but it'll be a lower sadness level. And so in this case, higher minus lower, 85 minus 5, for example, that's going to be a positive number. So like, really, so again, once again, we have a pre minus post, pre-family arriving home and post-family arriving home. But it didn't automatically mean it was negative. It depends in the context of the problem. So yeah, so that's why I'm saying like it's not that as easy as just reading it and knowing it. Like really personally, I'm highly encouraging all of you to write out that subtraction on the side and putting it in some values to help you see what would the result be. Does that help? Hopefully a little bit.
Sort of, but I think I'm gonna base it off if I either get a negative when it comes to calculating the test statistic.
Yeah, that's an excellent point, guys. Remember, down here, once you calculate the test statistic, I don't want to say always, because always is a very strong word, but the majority of the time, if this is negative, then this should be less than. If this is positive, then that should be greater than, right?
Sorry,
That's the
that
way
just
you could
came out of
check.
my head.
No, it's okay. No, that's okay, because that's what I do also. But that's what we all do. We all have to use these tips and tricks, you know, to like just double check. We're all human. We all make mistakes. So that's a great way to double check. But be careful, guys. The only time that wouldn't work is to use the test statistic to check, you know, the direction, is if this was a different than.
Yeah.
Right? If it's a different than it's like, okay, then you really got to just be confident with the work you're doing. Okay. So next, part B, calculate the difference in the table. And again, it's giving us the order. It's pre minus post. Okay, pre minus post. So 75 minus 85 is negative 10. 50 minus 45 is 5. 80 minus 85 is negative 5. 85 minus 95 is negative 10. 95 minus 95 is 0. Okay. To get the sample statistics, well, let's start with the sample size. How many paired samples do we have?
5.
5. And then I also want the mean, and I also want the standard deviation. Oops. So we're going to enter in those values in our calculator. So we do stat, edit, clear out your list. We're going to do -10, 5, -5, -10, and 0. Then you do stat, calc, one variable stats. And oh, these numbers just turned out so nice for the mean, like the last problem. I got -4 here.
Yeah.
And then for the standard deviation, I got 6.519.
Yeah.
Yes.
Okay, cool. All right, calculate the test statistics. So again, this is a paired sample hypotheses test. So feel free to use the formula from your flow chart. That's going to be x bar minus mu all over s over the square root of n. So it's going to be -4 minus 0 over 6.519 over the square root of 5, which gives us, let's see, I'm typing in my calculator, 6.519 square root of 5. I'm getting -1.372. Cool. Which, again, that matches, right? Negative, less than, right? Left tail. Not always, but most of the time.
So it would apply just for the different from.
Yeah, the only time it doesn't work is if it's a difference from. Yeah, that's you can't
I'll
check
have
it.
to worry about it.
P-value. So P-value equals, if this was a different from problem, what do we include?
2 times.
Good, a 2 times, good. This isn't though, so we're just gonna go straight to TCDF. Let's see, TCDF. Oh, perfect. Thank you. Negative infinity, -1.372. What comes next? Degrees of freedom, right? Which is what in this case? 4. So TCDF, negative infinity, -1.372, and 4. I'm getting 0.121, rounding it to 3 decimal places. And real quick, before I go any further, I want to throw another question at you. Okay, throw another question at you. Based on your sample mean, okay, does your sample mean follow or is in accordance with your alternative hypothesis, your alternative claim?
What's the question again?
Does our sample mean, does it fall in line? I'm trying to phrase it different ways. Does it fall in line with our alternative hypothesis or our claim?
Yes.
Yes, why?
Negative below.
It's -4. So the claim is that's going to be less than 0.
Oh,
Is -4 less than 0? Yes. So far, good.
It's still checking out.
Yeah, so we had a couple questions like that in our lecture as well. So I'm just throwing them at you. Okay. Let me back up. Let me do that with another one. Not confidence. It'll only be like this one. Oh, here is another one. Does your sample mean currently support or fall in line with or is in alignment with your alternative?
yes.
Yeah, just barely though, right? 59.714 is less than 60, but it still works. All right, good. So we did that a couple times also. Okay, so next our p-value is 12.1%. What was our level significance? 10. So is 12.1 less than 10?
No.
No, therefore it is not statistically significant. We do not reject the null and do not support the alternative. It is not asking for it, but if it were to ask what type of error may have occurred here, it would be type 2. Okay. Lastly, conclusion in the context of the problem. At a 10% significance level, the sample data do not support the claim that for students who do not do homework and only do tutorials will get higher exam scores. Something along those lines. I think I might have phrased it slightly different from what the problem explicitly said, but as long as it is getting across the same idea. Any questions? All right, guys, we're just about there. Only one more problem. Number 6. A random sample taken by the Bureau of Economics Analysis shows a comparison between mean income for Lakewood and Long Beach residents. Of 36 Lakewood residents, the mean income was $31,987, with a standard deviation of $5,000. Out of 49 Long Beach residents, the mean income was $33,179, with a standard deviation of $6,000. Construct and interpret a 95% confidence interval for the population mean. The degrees of freedom is 79. If it's okay with you guys, just because of the time, can we go straight into it?
Mm-hmm.
Okay. So list out and organize the sample statistics. Basically, all the info is given to us in the problem. It just wants us to identify it. So I'm going to separate it as Lakewood and then Long Beach. So for Lakewood, the sample size was 36. The mean was 31,987. And the standard deviation was 5,000. For Long Beach, the sample size was 49. The mean was 33,179. And the standard deviation was 6,000. Is everyone okay with that? We're just pulling it from the problem itself. Okay, find the difference in sample means. So it'll be x1 bar minus x2 bar. So let's see. That'll be 31,987 minus 33,179. 31,987 minus 33,179. I'm getting negative 1,192. So finding the critical value, remember there's 2 pieces of information we need here. You need your degrees of freedom, which is given for us here. The degrees of freedom is given to be 79. All right, we're just told that's what it is. There's no calculation that needs to be done here. And the confidence level, we are also given to be 95%. So since the degrees of freedom is so large, 79, you could use an external tool such as Desmos, like a computer, to do it. But I believe one of the formula sheets should be big enough. Because it's not on that formula sheet. It didn't go far enough. So
1.990.
it's like in here, right? As I keep going.
Yeah, this one.
Yeah, so 79. And then what was the confidence level? 95%. So 95%, 79 is 1.990. Remember, on the exam, you are not going to need to use this extra lengthy one. On the exam, it's any critical value will be from that smaller table. Okay? 1.990. So critical value is 1.990. Oh my god, I totally forgot at the start what we're supposed to do. Just identify what it is, right? One sample, pair, or two.
Two independent.
Two independent. Are we doing a confidence interval or hypothesis test? Confidence interval. Good. Okay. So that way now when it says to find the margin of error, I know where to go following the flow chart. So I go to two independent samples because it's Lakewood and Long Beach. And then from there it's talking about confidence intervals. So then I go up to the confidence interval box. And now it says find the margin of error. From that formula, it's T sub C times the square root of S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2. So that'll be 1.990 times the square root of 5,000 squared over 36 plus 6,000 squared over 49. Take your time entering that into your calculator. I'm going to do that myself right now. 1.990 times the square root of the fraction 5,000 squared over 36 plus the fraction 6,000 squared over 49. And I am getting 2,378.977. Any questions there? All right, so then the confidence interval, well, from your formula sheet, in case you forgot, it's going to be x1 bar minus x2 bar minus e, and then x1 bar minus x2 bar plus e. But we already found x1 bar minus x2 bar. We already did that here. All right, we already did that in part B. So I don't have to like rewrite all that. I could just write in what that solution was. It was negative 1192. So you have negative 1192 minus E, 2378 point. I'm going to go ahead and round to two decimal places here because we're talking about money, right? So I'm going to do 0.98. And then negative 1192 plus 2378.98. So we're going to subtract those values and then add those values. Do them separately. So I am getting negative 3,570.98 and 1,186.98. Oops, forgot to close that. All right, let's interpret this now. Again, feel free to look back here if you need to. So we're comparing the mean income for Lakewood and Long Beach residents, and we subtracted them, right? We subtracted them. So we're talking about the difference in the mean income. What was our confidence? 95, thank you. We are 95% confident that the mean difference in incomes between Lakewood and Long Beach, right, because we subtracted them, so we're 95% confident that the mean difference in incomes between Lakewood and Long Beach is between negative $3,570.98 and $1,186.98. I'll give you a second and I'm going to throw a couple more questions at you. So, based on this confidence interval, is it possible that Lakewood has a higher mean income?
Yes.
Is it possible that Long Beach has the higher mean income? Is it possible that they have the exact same mean income? Yeah, because remember, this is ranging from negative to positive and zeros in between.
I forgot.
So that means like anything is really possible. We can't really say one way or the other. The only way you could say for certain that one is going to be higher than the other is if it was fully positive or if it was fully negative. Because then that indicates like for sure this group has like a higher mean income. Because our confidence interval is strictly positive or our confidence interval is strictly negative. But if you ever have a mix like this, then it's like, well, this one could be larger, or that one could be larger, or they could be exactly the same because zero is in here too. And if they're exactly the same and subtract them, you get zero. So, that's it. We did it, guys! We did it! All right, let me stop the recording. I have 11% left about.